In this video, we will practice identifying measurement apparatus and describing accurate and reliable measurement methods for given experiments. Before we begin looking in detail at various types of apparatus, it's important to make sure that we all understand the difference between accuracy and precision in a scientific context. Accuracy is a measure of how close the value you obtain from an experiment is to the true value. On the other hand, precision is how close your various measurements are to one another. Let's illustrate the differences between accuracy and precision with some examples. A common way to explain these concepts is with a dartboard. Imagine that you throw 3 darts at a dartboard. Accuracy would be a measure of how close your darts are to the bullseye, which is in the centre of the dartboard, while precision would be how close your 3 darts are to one another. On this first dartboard, you can see that all 3 of our darts are very close to the centre. This means our darts are accurate. Moreover, the 3 darts are very close to each other, which means that they are also precise. Let's have a look at another example. This time, when we look at our 3 darts, we can see that none of them are close to the centre. This means that our darts are not accurate. However, the 3 darts are close to one another, so they are precise. Now let's look at our third example. Although our 3 darts aren't exactly on the centre, they do average out at a point on the centre. Because the average of our measurements is on the centre point, our results are accurate. However, our darts are not close to one another, so these results are not precise. And finally, we have 3 darts which are neither near the centre, nor are they close to one another, so these results are not accurate and not precise. Let's visualise this in another way. Let's imagine that we're performing an experiment and the results that we're recording are numbers between 1.3 and 1.6. It doesn't really matter what it is we're recording for this. And let's imagine that the true value is 1.45 for argument's sake. If we made 3 recordings like this, we would say that our results are both accurate because they're close to the true value and precise because they're close to one another. If we had results like this, we would say that they are accurate because they average out to roughly the true value, but they are not precise because our values are not similar to one another. Results like this, however, we would consider not accurate since they're nowhere near the true value, but they are precise because they are close to one another. And results like this would be neither accurate nor precise. Now that we understand the difference between accuracy and precision, let's start looking at some scientific apparatus. First, let's look at different ways we can measure a solid. Of course, the best way to measure out a solid is by using a balance. In fact, there are actually different types of balances depending on what you're weighing out. The most common balances that you might come across are balances which are accurate to 2 decimal places, and sometimes balances which are accurate to 4 decimal places. You may hear these referred to as a 2-figure and a 4-figure balance. The 2-figure balance is the one which is ideal for the majority of the work you'll do. On the other hand, the 4-figure balance is used for very accurate work, or when you need to weigh out a very small amount of something. You can tell the difference by looking at how many decimal places the display shows. You'll also notice that a 4-figure balance will have some kind of housing around it. This is because when making such accurate measurements of mass, any airflow over the top of the balance can upset the reading. So to combat this, we put a house on the top. This is of course see-through, so you can still read the value on the balance display. Now let's look at how to use one of these balances correctly. The first step is to place your measuring container onto your balance. You should always use a wide-necked vessel for weighing material out. A beaker would be okay, for example, or a weighing boat is even better, but you shouldn't use something with a narrow neck, like an Erlenmeyer flask, for example. This is to reduce the chance that you'll spill your solid over the bench, since this could create a hazard and is wasteful. Weighing boats are specifically designed for this purpose. You can get aluminium foil boats, for example. These come with a handy tab to carry it with, and are also flexible so that you can bend the boat in order to add your solid to a reaction vessel easily. You can also get flexible plastic boats. These are useful because you can weigh out into a nice wide-necked boat and then curl the boat into a straw shape so that you can easily insert it into a narrow-necked reaction vessel and put all your solid in without spilling it. Once the container is on your balance, you'll need to set the display to 0. There will usually be a prominent button saying 0 or tear on the front of your balance to do this. Now we are able to weigh out our substance. You could do this by simply putting the solid into the weighing container whilst it's on the balance, using something like a spatula. But this isn't really the best practice. It's better to take the weighing boat off the balance, to put your solid into it, and then replace it back on the balance. This prevents you from dropping any solid onto the balance, which could damage the balance pan or the springs underneath. You simply repeat this process of taking the substance off the balance, adding a bit more, and then placing the boat back on the balance until you reach the desired mass. Once you've reached your final amount, make sure to record exactly what your final mass is according to the balance. So this is how we measure out a solid, but what about a liquid? We have a variety of glassware options if we want to measure out a liquid. Perhaps the most commonly used apparatus for measuring a liquid is the graduated cylinder, sometimes called the measuring cylinder. Graduated cylinders come in a variety of sizes, for example 1 milliliter, 5 milliliters, 15 milliliters and so on. Select the most appropriate size for the amount of liquid that you want. If you need half a milliliter, for example, you'd probably want the smallest cylinder, 1 milliliter. You would fill it to halfway, to the 0.5 milliliter line, and then empty it into your reaction vessel. If you needed to measure out 3 milliliters, you could use the smallest, the 1 milliliter cylinder, 3 times, but that might get a bit tedious. You might be better off using the 5 milliliter cylinder. You could also use the 15 milliliter cylinder, and that wouldn't be wrong, but it is more difficult. Because you have such a large cylinder and you're only adding a small amount of liquid, it's more difficult to read the measurements. So the 5 milliliter cylinder would be better. Let's have a look at how we read the measurements. Here's a close-up of a measuring cylinder. Now let's add our liquid. How would we read this volume? The rule that we use is that we always read from the bottom of our meniscus. The meniscus is the skin-like surface of our liquid. you can see that our meniscus is higher at the edges of our cylinder. But it's the very bottom that we need to read from. In this diagram, we can see that the bottom of our meniscus is in line with this graduation. So this volume would be 1.2 millilitres. We use the same technique when measuring volume using a pipette. There are two main types of glass pipette, volumetric and graduated. Volumetric pipettes come in various sizes and are good for measuring out set volumes, for example 25 millilitres of a liquid. Graduated pipettes, on the other hand, are useful in a similar way to graduated cylinders. You can measure out a wide variety of different volumes with a graduated pipette. You simply fill the pipette to the marking that you need, measuring from the bottom of the meniscus, remember, and then empty your pipette into the reaction vessel. Glass pipettes like these can come with different accuracy gradings. This tells you how accurately that particular piece of glassware will measure the volume that it says. You can use higher accuracy grading glassware for more accurate work. And of course, you can also use a burette to measure out a liquid. To do this, you simply add your liquid to the burette, making sure not to add any more than the top line, and then dispense the required amount using the tap at the bottom. You might ask, can we use an Erlenmeyer flask, sometimes called a volumetric flask, to also measure liquids? The answer is not really. They're in no way accurate. The same is true of beakers. The markings on the side of these bits of glassware are really just a rough guide and shouldn't be used for measuring. You might also ask, well, could we not weigh the liquid in a similar way that we weighed out our solid? It isn't wrong to weigh out a liquid, but it is a bit more tricky than weighing out a solid. When you weigh out a liquid, you also need to take into account the density of your particular liquid. So most of the time, it's easier to work with volumes. Now that we've measured both liquids and solids, let's look at gases. Perhaps the easiest way to measure a gas is with a gas syringe. You attach one end of the gas syringe to the gas that you'd like to draw up, or to your reaction vessel if you're measuring gas production, and then you draw or watch the plunger move and measure using the markings on the side. Another way to measure gas produced by a reaction is with an upturned graduated cylinder. The tubing from your reaction carries the gas into the upturned cylinder, which is initially full of water. As bubbles are produced and enter the upturned cylinder, they displace the water and the water level drops. You can then use the markings on the side of the cylinder to work out how much gas has been produced. This works just as well, but is slightly more fiddly to set up. Now that we've learned how to measure gases, liquids and solids, let's put this to use in an experiment. Let's imagine that we're carrying out this reaction. We have calcium carbonate reacting with hydrochloric acid to form carbon dioxide, water and calcium chloride. Note that this equation is not balanced. We are told that we need to measure the production of this particular product, CO2 gas. So let's work out which apparatus we're going to need. Our first reactant is calcium carbonate, which we're told is a solid. To measure out this solid, we're going to need to use a balance. The first thing we'll need to do is select a weighing container. We're going to want something wide-necked, like a weighing boat. Now that we've placed our container on the balance, we need to set the display to 0. This is sometimes called tearing the balance. Next, we need to weigh out our calcium carbonate. Remember that the safest way to do this is to take your container off the balance, add some of your solid, and then put it back on the balance, repeating this process until you get the mass that you require. Once you've weighed out the correct mass, remember to record the value. Next, we need to measure out our hydrochloric acid. Because our acid is aqueous, this means measuring out a liquid. To measure a liquid, we could use a graduated cylinder, pipette or burette. The experiment tells us that we need 25 millilitres of hydrochloric acid. So we could use a 25 millilitre graduated cylinder, a 25 millilitre volumetric pipette, or a 25 millilitre graduated pipette. We could use a burette, but it's not the best piece of equipment for this. Burettes are more useful when you're not sure quite how much you're going to need to add, so you add a little bit at a time until you reach the point you need. For example, in a titration experiment. Remember to always read from the bottom of the liquid's meniscus. Finally, we need to measure the production of our carbon dioxide gas. The easiest way to do this is with a gas syringe. You simply attach your gas syringe to tubing connected to your reaction vessel and watch the plunger of the gas syringe move. Now that we've put this into practice, let's summarise what we've learned. Accuracy is how close you are to a true value, while precision is how close your measurements are to each other. We measure solids using a balance. Remember to always use a wide-necked container to measure your solid out in. To measure a solid, you first place your container onto the balance, then you set the display to 0, weigh out your substance and record the final mass. When measuring liquids, we tend to use graduated cylinders, pipettes and burettes. To measure out a gas, we use gas syringes or water displacement equipment. And always remember to measure from the bottom of your meniscus.